Welcome to the finalToon tutorial, Transparent Objects. In this tutorial we will discuss how transparent objects are handled in finalToon and why there is several things you need to consider when you want to do scenes that include transparent objects. finalToon is a true line renderer. This means that finalToon is able to render even hidden lines of an object or occluded lines. So this is done with a true line renderer. The big disadvantage of such line renderers is the problem of transparent or reflections. Transparency isn't so easy for a true line renderer because the line rendering process itself is the view dependent effect. So the lines change according to the orientation of the object or according to the camera viewport and so on. So it is not possible for a line renderer to render correct reflections, refractions, or even just simple transparent objects. And even worse, some line renderers need the C buffer or G buffer information, and usually scanline renderers just throw away all the G buffer information behind transparent objects. However, finalToon has a clever solution for this kind of stuff, so in most situations you can steal away with the finalToon tricks. And we are now going to explore these little tricks we have implemented in finalToon that allows you to render even lines behind transparent objects. First, I would like to show you this little scene here. It's a little bit modified from the scene you get with the original distribution on the CD-ROM. So we have modified it in only one way. We have put a box object in front of the camera. So in the viewport here, you can see there's a transparent object in front of the camera. And this transparent object covers half of the image, or the right side of our street here. So usually you would expect that you can look through your transparent object, as you can see it here, and you would see any effect also through the transparent object. So let's just do a first rendering so that we can just check what's going on here. As you can see in the rendering, we have the transparent object here, and now finalToon is ready with the rendering. And as you can see, everything that is covered or behind the transparent object will not show any finalToon effect. It is like if the effect isn't applied to this side of the street. Now let me just prove to you that this isn't the case. The lines are applied to all objects in the scene. So what I will do is just I use the properties, and I'll make the object invisible to the renderer, and we'll just render again the scene. And now you will see in a second that the finalToon effect in fact is applied also to this side of the street. So the only difference we had from before was that our transparent objects was visible to the renderer. So before we start changing something in the scene, let's analyze the setup as it is right now, and as it would probably be when you try to do such a scene with a transparent object. I'll open the material editor, and we can see that there are 4 active materials. One material is the environment map, so we don't need to care about this. And the other 2 materials is, this one is the street, and this is the material for the buildings. So also there we don't need to really look very deep into it. Let's just have a a fast check of the settings. So this is the material of the building. It's just a pretty easy activated thing. finalToon shader, just everything gray. With the settings we have here, the brightness for the shadow, we get a darker shadow here, as you can see. And also the highlight with 150% means that we get a little bit of highlight up here. So all default settings, nothing special. And in this tutorial, it wasn't the idea to have some fancy toon shading or whatever. The interesting thing is that we use the finalToon edges here on a material basis. Also, this is pretty easy. We were not really creative here. We did just drag and drop and instance the same settings. It's a black line style, a black line with a thickness of 2. That's all we did for the line setup here. The same for the street material, except in the street material we did a different setup. In the street material we used just a thinner line style here to make a difference between the big buildings and the line definitions. That's all. And as I said, we're not caring much about the material setup right now. That's not the point in this tutorial. Let's see the most important thing we want to discuss here. This material here, the transparent material. And right now we can see this is a transparent material. It's a finalToon material because we wanted to control the lines. We could have also used the default edges, but then every object will get the same line style, and this is what we don't want. We did want to see, for example, the outline of the glass object of the window here. So if we would have default edges, we would see outlines along the window, and this is what we didn't want to see. So this is why we have chosen for the transparent object a finalToon material, because in the finalToon edges rollout menu we are able to uncheck the enable edges option. This means that this object will not get any lines at all. Because we don't want to see the glass or the window, we want to look through, and this is why we have disabled the lines. And what we did is something obvious. We wanted to look through, so we changed the opacity here to 20%. So that means it's pretty transparent, but with the disadvantage that we are not able to see through and see the lines in the background. Let me just bring up the rendering again, just as a little reminder. So finalToon is active now here, drawing the lines. As you can see, no lines here. So how do we solve this problem? We want to see the lines through the glass, and maybe even through the tinted glass. As you can see, we have a blue here. So we want to see the lines behind the glass object. So now we're going to raise the opacity to 100. So now we don't get the transparency effect at all. finalToon has a very clever trick to overcome the problem of a line renderer. We use a refraction mapping. The great thing is, because it's a map, it's a separate render path, so the lines are rendered in a separate path, and then the lines are mapped onto the object. So I'll activate the refraction here, the refraction map, and I'll choose one of the finalToon materials here, or excuse me, maps. The finalToon maps are available for mirror, so we have a flat mirror finalToon map. We have a special map for hatching, that's a different tutorial, and we have a finalToon refraction map. That's good for curved surfaces, and we have the thin wall refraction map, and this is what we are going to use right now. The thin wall refraction map works identical to the thin wall refraction map you know already from 3D Studio Max. The only thing we did is we added some finalToon magic to it. So if you use the thin wall refraction map of finalToon, you get the trick that the lines are rendered. So right now I wanted to simulate a window, so I don't want to see any refraction or distortion effect. So I'll turn this to 0. That's the thickness offset. And also I don't want to see heavy blurring, so we could even simulate frosted glass, for example. So I'll just check off the blur, the apply blur option, and I'll go back, and as I said, we wanted to have some tinted glass effect, so I'll just turn this down to 80%. So this will give us 80% thin wall refraction and about 20% of the settings we did here above. And when I render now, you will see right away the big difference it makes. In our first refraction pass, the lines are rendered, and you can see in the rendering the lines are already there, and later in the video post pass the lines for the other areas are rendered. And now we have the great thing we wanted to have. On this side of our image behind the glass, we can see the lines of finalToon. And most of the time this really works very well. It's an easy, perfect and fast solution for transparent objects for a true line renderer. So in most situations you can use this kind of solution. Remember, let me just show you again what we did here. So because we used the refraction mapping, we didn't have to change or play around with the opacity. You may still do so, but you don't need to. So you can keep this at 100. Then what we did is the little trick. We have chosen the finalToon thin wall refraction map, and this gives us all the power of the refraction map. And we could even apply a blur, so let's do a little bit of strong blur effect, and you will see right away that we are even able to simulate frosted glass that creates a really blurry look. And also the great thing is we can have a bump map distorting our transparent object. So if we add a bump map, let's say I'll add a cellular map to it and we'll render, you will see that the whole image is distorted as you would expect it if the object has a bumpy surface. And this gives you real amazing creativity as you can animate everything. So finalToon follows the philosophy of 3D Studio Max, animate everything. So you can animate the objects, you can animate the line styles, you can animate even the bump map to get very interesting looking watercolor effects or whatever. So it's up to your creativity what you want to do with finalToon. So let me just turn off the bump map effect again, and also bring down or turn off the blur completely. As you have seen, it is possible to render transparent objects with finalToon. However, there are still restrictions. They're the same restrictions as you know them from 3D Studio Max. It's a scanline rendering system. So the restriction is, for example, if you have multiple layers of transparent objects, you might run into trouble. So multiple layers of transparent objects can cause real pain. I'm now going to duplicate the transparent object to create a scene that shows us the difficulties we might run into when we have multiple layers of transparent objects in finalToon. For this, I'm going to zoom into the top viewport, and also I'm going to duplicate the object. I do this just by moving the object, holding the Shift key, and just giving the object a little bit of an offset. And as you can see right now, up here, we have our two transparent objects. And those transparent objects are creating two layers. So we have layer 1 and layer 2 here. And our camera is here. So we're trying to look through exactly two layers of transparent objects. Now let's take a look at the rendering. We want to see how the rendering looks like. And what's going to happen is that because we're using a thin wall refraction effect, we have the same restrictions as you know it from 3D Studio Max. Perhaps you never tried out the thin wall refraction, so you might not know the restrictions. One restriction we have here, because it's a pure scanline rendering effect, the order of rendering the object plays a big role. And again, it's just a trick to simulate transparent objects or refractive objects with scanline rendering technology. So you can see in the rendering what the problem areas are right now. So when those two objects overlap, we don't see anything. So in this area, we don't see a single line or even the objects behind it. Right now, this is not a mistake. This is a standard behavior that is expected by using a scanline rendering trick. And also, just as a little reminder, line rendering is a view-dependent effect. So this means even a ray tracer can't help us here because the lines are drawn view-dependent. And it would mean that we have to do separate renderers for each view in the glass or transparent object. So right now, using scanline rendering is a very clever way to overcome the restrictions. But as you can see, in this case, we still can't look through. Thanks God, there is a really nice and clever function built in 3D Studio Max. As you might know, 3D Studio Max has one of the fastest scanline renderer and also one of the most advanced scanline renderers. So if you want to get around this problem, you would open up the render dialog, and perhaps you have never used this, so I'll highlight it here again. The auto refract maps menu entry in the rollout dialog. Remember, this is an effect of the Max Scanline standard scanline A buffer. So setting here the iterations to a value higher than 1 will give us the chance to look through multiple layers of transparent objects. So I'll just increase the number of iterations to a value of 2, and this should give us the ability to see through those two transparent objects. So let me just start the rendering again. Now watch closely up here. The rendering refract maps will run through 2 times, and this will give us the option to look through the effect. And as you can see, it takes a little bit longer to render the effect because it's a separate rendering path, but now we get the correct result. We can look through all areas and regions. We can look through the first level, also here this is the first level, but also the second level transparencies we can look through. So there is a clever solution, a clever way to still create complex toon scenes or illustration renderings with transparent objects. You just need to remember the little trick about the iteration count for the reflect maps. And also remember, this is not a restriction created by finalToon. It's a standard restriction you have in 3D Studio Max or scanline rendering, but as we just proved, you can get around this problem by just using the iteration count. So just remember, when you're doing refractive or transparent objects and you start to see some strange effects, just remember about the iteration count. This might solve the scene for you. Still, there might be very complex scenes, and there is no way around to go into post effects, but then there is really no way around. But for the most scenes we have found, this is a perfect solution, and it works just with a button. Just press the render button and you get a nice and good looking result. Also, let me remind you about checking out the other tutorial videos. We have several tutorial videos on the CD-ROM, so just check them out and try to understand how finalToon is working with 3D Studio Max.